Hi, this is also a numerical class based on Gauss's law. The last class we discussed the two numericals 1.15 and 1.16 of the textbook, page number 47. And today I want to discuss the numericals 1.17. So what the numerical say? The careful measurement of electric field at the surface of a black box indicate the net outward flux through the surface of the box is 8 into 10 to the power 3 Newton meter square per coulomb. What is the net charge inside the box? If the net outward flux through the surface of the box were 0, that is the second part, could you conclude that there were no charges inside the box? Why or why not? Okay? So what the question say? Question say that the total electric flux linked with surface of a black box. So this black box, the name of the black box has no meaning. It is simply a cubical box. This black box is simply a cubical box. And what is the electric flux linked with the cubical box? It is 8 into 10 to the power 3. What is Gauss's law? Phi is equal to Q by epsilon 0. What is Gauss's law? Phi is equal to Q by epsilon 0. What is the total outward flux linked with the surface of the black box? It is 8 into 10 to the power 3. What is the value of epsilon 0? 8.854 into 10 to the power minus 12. Therefore, Q is equal to, you cross multiply it, Q is equal to, we are getting 7.08 into 10 to the power minus 8 coulomb. That is the charge inside the black box. What the second part of the question say? Second part of the question say that if net outward flux to the surface of the black box were 0, what type of conclusion can you make? Okay, what type of conclusion can we make? What is actually phi? Phi is equal to Q by epsilon 0. This Q is not a single charge. It is summation of total charge inside the closed surface. Since in the question they said that the net outward flux is 0, that is phi is equal to 0. If phi is equal to 0, Q will be 0. It said that if the net outward flux linked with the surface of the black box is 0, if phi is equal to 0, Q is 0. If inside the black box there is a single charge, then Q is 0. That means inside the black box there is no charge at all. But if Q is the summation of charge, then phi 0 means key. Summation of Q 0. That means inside the black box there are two charges or three charges, and magnitude of total positive charge is equal to magnitude of total negative charge. So therefore it implies that either inside the black box net charges is equal to 0. Net charges 0 means inside the black box 2 or 3 charges are there. They are of different sign. Some of the charges are positive and some of the charges are negative. But if we add the magnitude of all charges, then magnitude of positive charge is equal to magnitude of negative charge. So if I add all of them, then due to positive and negative they cancel each other. That means if total electric flux linked with a closed surface is 0, it implies that inside the closed surface there is no charge at all, or net charge inside the black box is equal to 0. Is it okay? So this is the question 1.17. And next one 1.18. So this is a diagram. It is a square plate of 10 centimeter a side. This is a square plate 10 centimeter a side. Okay, at the center of the square plate At the center of the square plate means from here to here 5 centimeter, from here to here 5 centimeter, from here to here 5 centimeter, from here to here 5 centimeter. At the center of, from the center of the square plate at a height of 5 centimeter, a surge is there. A surge is there. You just see a point surge 10 microcoulomb is at a distance 5 centimeter directly above the center of a square plate of side 10 centimeter as shown in figure. What is the magnitude of electric flux through the square plate? In the question, it is said that a point surge of 10 microcoulomb is at a distance 5 centimeter directly above the center of a square plate of side 10 centimeter. Question number is 1.18. What is the net electric flux linked with this square plate due to this surge? Okay, it is the question number 1.18. So this is the square plate. In this case, due to this surge, electric field at different point of this plate is not constant, is not uniform. Due to this surge, electric field at this point, at this point, and at this point, at this point, they do not have the same magnitude. That means the electric field associated with this square plate due to this surge is not uniform. Therefore, in order to calculate electric flux, we cannot use that equation that flux is equal to E dot A, dot product of electric field intensity with area factor. So we have to go for the second option. What is the second option? Second option is the, what is the second option? Second option is the application of Gauss's law. But for the Gauss's law, a closed surface is required, but it is an open surface. It is an open surface. So in order to complete, in order to get a closed surface, what we have to do, I have to add 5 more identical square plates like this. One plate is here, one plate is here, one plate is here, one plate is here, and one plate is here. I have to add 5 additional square plates around this square plate, given square plate, so that it form a cube. Have you seen? So this is the given square plate at a height 5 centimeter, 10 microcoulomb is there. So in order to apply the Gauss's law, I arranged 5 additional square plates in such a way that the given charge is inside the cube. Now, what is the flux associated with this new cube, whose side is 10 centimeter? It is Q by epsilon 0. What is Q by epsilon 0? Q is 10 microcoulomb. Micro means 10 to the power minus 6. We are getting phi is equal to 1.29 into 10 to the power 6 Newton meter square per coulomb. But in the question, they asked to find out electric flux associated with this square plate, not the whole cube. So total electric flux linked with the whole cube is this, Q by epsilon 0. Q by epsilon 0. Is not it? So what is the flux linked with it? 1/6 of this flux. 1/6 of this flux. Why? Because cube has 6 faces. This total flux is associated with all the 6 faces of the cube. So what is the flux linked to it? What is the flux linked to it? One face of the cube. So phi is equal to flux linked to it one square plate. One square plate is total flux divided by 6. If it is total flux divided by 6, so what is total flux? 1.29 into 10 to the power 6 divided by 6. If I do this, it is 1.85 into 10 to the power 5 Newton meter square per coulomb. Or instead of proceeding in this way, we may proceed in this also. What is the flux associated with one surface of the cube? It is total flux of the cube divided by 6. What is total flux? Q by epsilon 0. That means it is 1 by 6 into Q by epsilon 0. This is 1 by 6. What is Q? 10 microcoulomb. What is epsilon 0? We are getting 1.88 into 10 to the power 5 Newton meter square per coulomb. Is it okay? Is it okay? So in the question they say that a square plate is there 10 centimeter aside. From the center of the square plate at a height 5 centimeter, a charge of 10 microcoulomb is there. We have to find out what is the flux associated with it. Due to this charge, electric field at different point of this plate is not constant. That means electric field due to this charge is not uniform here. Therefore, if we want to calculate electric flux from E dot A, dot product of electric field intensity with area vector, it will be a mathematically a very tough approach. Mathematically টান approach হ'ব. So therefore, we have to apply the Gauss's law. But for the Gauss's law, we require a closed surface enclosing the volume. But this is an open surface. Therefore, I take 5 identical additional square plates. And this is the first plate, it is given here. This is the second plate, this is the third plate, this is the fourth plate, this is the fifth plate, and this is the sixth plate. So if I arrange the plate in this way, what we are getting? I am getting a cube 10 centimeter aside. And the given charge 10 microcoulomb is inside the cube. So what is the flux linked to it whole cube? It is Q by epsilon 0. What is the flux linked to it whole cube? It is Q by epsilon 0. Okay? But what is the flux linked to it one surface of the cube? Since a cube has 6 faces, flux linked to it one face of the cube is 1/6 of the total flux. 1/6 of the total flux. Phi 1 by 6. What is phi 1? Phi 1 is total flux linked to it. What is phi 1? It is Q by epsilon 0. So in this way, we are getting this. So you may approach in this way or in this way. Okay? Today, I stop the class.